The advantage for token 30,000 is 0. 4. That's a strong positive signal concentrated on this one decision. Token 30,001. The agent starts writing the fix. The critic's estimate moves from 0.7 to 0.75. Advantage 0.05. Token 5 import OS had the critic at 0.15 before and 0.15 after. Advantage 0.0. The import didn't change anything about the expected outcome. No signal, no reinforcement. Token 12,000, the wrong diagnostic path had the critic at 0.25 before and 0.22 after. Advantage minus 0.03, slightly negative. The critic noticed the agent was drifting, and the expected outcome dipped marginally. This is per token credit assignment. Every token gets an advantage proportional to how much it actually changed the expected outcome. The generation cost problem vanishes. The critic is the baseline. One trajectory per prompt. That 2-hour coding task needs 2 hours of generation compute, not 16. The training pipeline can actually run. The compaction problem dissolves. The critic computes value estimates from the context it sees at each position. If the agent has compacted its history, the critic evaluates the compacted state directly. It doesn't need structural alignment between parallel rollouts. GLM-5.2 takes this further. It explicitly trains the critic on compacted subtraces, forcing it to learn value estimates from degraded context. The zero-signal problem resolves through the critic's temporal learning. Consider the all-fail scenario. 8 trajectories all failing. GRPO, no learning. Critic PPO. The critic predicted moderate success at various points. Those predictions were wrong. The critic updates its value estimates downward. The gradient isn't zero, it's informative. It teaches the critic where the trajectory started going wrong. Over successive training iterations, the binary pass-or-fail signal propagates backward through the critic's value landscape. The critic learns intermediate markers, states that reliably precede success or failure. The terminal reward is one number. The critic distributes that number backward into per token credit across the entire trajectory. That's the transformation. Let me pull back for a moment and restate where we are. We've covered the 3 inference optimizations: DSA cutting reading cost, index share amortizing selection, MTP compounding writing speed, and why the standard training approach, GRPO, breaks on long horizon work. We just built the alternative, a critic network that provides per token credit assignment instead of trajectory level averages. Now comes the payoff. This is where the mechanism stops being about GLM-5.2 and starts being about any system that trains agents for long-horizon, high-stakes work. Consider training a legal AI agent. The trajectory isn't a short code function. It's a full matter workflow. The agent reads a 200-page acquisition agreement. It extracts clauses. It identifies representations, warranties, indemnification provisions, limitation of liability caps, and their exceptions. It evaluates how those clauses interact. It checks for internal contradictions. It drafts analysis. It incorporates review feedback. One trajectory can produce 100,000 tokens or more. GRPO first failure hits immediately. 8 rollouts require 16 to 32 hours per training prompt. Economically impossible for realistic training volume.